Section 7.5, solving radical equations. A radical equation has a variable underneath a radical or a variable to a rational exponent. And remember, a rational number is a number that can be written as a fraction. Always check for extraneous, which means false, solutions. So that means when you plug the answer back into your equation, to the original equation, if you get something that does not make it a true statement, then it is extraneous. So these are the steps that you're going to follow in order to solve for your radicals. So you're going to isolate the radical expression involving the variable. If more than one radical expression involves the variable, then isolate one of them. Raise both sides to the equation to the index of the radical. If there is still a radical in the equations, then you're going to repeat steps 1 and 2. Otherwise, solve the resulting equation and check the answer in the original equation. So for number 1, notice that my radical expression part is right here. So that's the part that I want to get by itself first, or isolate. So in order to do that, I have 7 that is added. I need to subtract 7 to the other side. So when I subtract 7 to the other side, I get the square root of a minus 3 is equal to negative 6. Now after I isolate it, I'm going to raise both sides of the equation to the index of whatever the radical is. So notice that the index, when it's not written, remember, is 2. So you can write it in if you want to. So that means I have to take both sides to that index to get rid of the radical, because if you remember, if I have the square root of something squared, that takes the radical away and gives you x, or if you have like the cube root of x cubed, that gives you x. That's why we take whatever the index is and take it to that power of both sides, and if you do one thing to one side, you have to do it to the other. So in this case, when I do that, squared makes this just a minus 3 is equal to, and negative 6 squared gives me 36. And then all I have to do now is just solve the equation for a by adding 3 to both sides. So I get a is equal to 39. Now I'm not done because I want to check my solution, so I'm going to check. So when I check this, I put my number back into my original equation. So I get 7 plus 39 minus 3 is root 36. Has to equal 1. So the square root of 36 is 6. So in this case, we get 7 plus 6 equals 1. And we get 13 equals 1. If you look at this, you notice that that is not a true statement, since 13 does not equal 1. So that means that a equals 39 does not work, so there are no solutions. So this right here would be the correct answer. That's why it's important when you're doing these problems to make sure to check your answer. And the reason this happens is if you look back at this part of your equation right here, you have the square root of something equals a negative number. Can you ever get a negative answer when you take the square root of something? No, so that's why there's no solutions there. So number 2. So same thing. First thing I want to do is isolate my expression with the radical. So I want to subtract the 2 to both sides. And I get the square root of 3x minus 2 is equal to, in this case, 4. Since my index is 2, that means I want to take both sides of my equation to the power of 2. That eliminates the radical from the left side of my equation. So I get 3x minus 2 is equal to, and 4 squared is equal to 16. So now I'm solving this equation. So add the 2, divide by 3, and you get x is equal to 6. I'm not done. I want to check my solution to make sure it's not extraneous. So if I go back over, I have 2 plus the square root of 3 times 6 minus 2. It has to be equal to 6. So 3 times 6 gives me 18, and 18 minus 2 gives me the square root of 16. And then 2 square root of 16 is 4. So 2 plus 4 is 6, so 6 equals 6, so that checks out. So that means x equals 6 works as a solution. Now, if we look at number 3 here, this is a little bit different than the other ones because we have two radical equations with two variables. So when this happens, pick one of the variables or one of the radicals that you want to isolate. It doesn't matter which one. So I'm going to pick this one to isolate because it's positive. So I'm going to add root 3 plus r and put it on the other side. So this would be plus root 3 plus r to both sides. So when I do that, I'm going to write this in a different color. I get square root of 2r minus 6 is equal to the square root of 3 plus r. Since the index is 2, that means I'm going to square both sides. When I do that, notice that gets rid of both my radicals in this case because they're both square roots. So you get 2r minus 6 equals 3 plus r, and then you're just solving your equation. So I'm going to add the 6. I get 2r is equal to 9 plus r, and then got to solve. So I'm going to subtract the r. And I get r is equal to a value of 9. I'm not done because I want to check this solution to make sure it works into my original equation. So let's check. So 2 times 9 gives me my 18. And then this is going to give me the square root of 12 minus, and 9 and 3 gives me the square root of 12. These are like terms because they have the same index, the same radicand. So root 12 minus root 12 is just 0, and 0 equals 0, so it checks out. So now let's look at the next one. For the next problem, we have two radicals. One of them is already isolated by itself. That's this one right here. So I can't really do much besides then square both sides. I could, if I wanted to, take this -1 right here and put it on the other side, but that's not going to change anything really. So I'm going to leave it where it's at since one of my radicals is already by itself. That means I'm going to square both sides. When I do that, I know that this radical is going to be gone, but on the other side, notice you have a binomial squared. Remember, whenever we have a binomial squared, that means you need to FOIL or box it. So this really says we have the square root of x plus 21 minus 1 times the square root of x plus 21 minus 1 equals x plus 12 because we got rid of the radical on this side when we squared the radical. So now I need to multiply this out. I can FOIL it or box it, so I'll go ahead and FOIL it. So the first terms, this times this, would cancel out the radical because you really have the square root of x plus 21 squared because you have two of them. Then you multiply this times the 1, so minus the square root of x plus 21, and then your inside terms minus the square root of x plus 21, and then your last terms would be -1 times -1 is +1. And then we want to simplify this, so this first term that we have right here, the square root of x plus 21 squared, that takes care of the radical, so this is really since we have a group of 2, we can take the x plus 21 out of the radical. And I have the root x plus 21 and x plus 21 are like terms, so I have 2 of those. So minus 2 root x plus 21 plus 1 equals x plus 12. So I'm going to go over here. So now I want to combine like terms. So if I look back over here, I have the 21 and the 1 that are like. So I got x minus 2 roots x plus 21, and then 21 plus 1 gives me 22. And then if you look here, notice you have like terms on either side of your equal sign. So that means you're going to want to combine terms on either sides of your equal sign. So subtract the 22 I took the 22 to the other side, to the right, because I want to get the radical by itself again. And then subtract the x. These cancel out. And I'm not done because I still want to get that radical by itself, so I'm going to divide both sides by -2. So now I'm back to where I started again. So the next thing I have to do is get rid of the radical. So it's an index of 2, so I'm going to square both sides. So I get x plus 21 equals 25 when I do that. And then all I have to do is solve for x, take the 21 and subtract it to the other side, and you end up with x is equal to 4. And then don't forget you want to check your solution by plugging it into your original equation. So when we do that, we get 4 plus 21 is 25, so the square root of 25 is 5, and 5 minus 1 gives me 4. And on the other side, we get 4 plus 12 is 16. The square root of 16 is 4, so it works on that side. So this checks out. We're good. So for this one, it was a little bit trickier because that -1, we had to multiply it out. So we isolated one radical, FOILed it out, and then we had another radical we had to isolate, which we did, and then solve. So we're going to do number 5 in class, but if you want, you can try to do that on your own and see if you get it. Now, notice the difference between these problems and the ones we just did is that these have rational exponents, which means that these are really radical problems that we're solving for. So you're going to do the same thing. You can leave them in this form, or if you like, you can put it in radical form. That's up to you. So I would just leave it in this form and solve. So you want to solve for the radical part, which is right here. So in order to do that, I would divide both sides by 2 first. And so we get x plus 3 equals, or to the 3/2 power, equals 27. Now for this one, if I have a power 3/2, I want to get rid of it. So the only way that I can get rid of it if it was 1. So if I have 3/2, what times 3/2 would be equal to a value of 1? Well, I know that 2/3 times 3/2 equals 1. So notice that all I did was flip it. So in this case, when this happens and you have these exponents, you can take both sides to the reciprocal of that power. I'm going to rewrite this over here so I can write it larger. So we have so I'm going to take both sides to the 2/3 power. Oops, to my parentheses there. That's all right. I just add another one in. And when I do that, 3/2 times 2/3 is 1. So now I have x plus 3 by itself equals, and then I can do 27 to the 2/3 in my calculator. If it gives me a decimal, see if you can hit the math fraction key and give it a nice number. If you can't, then you just got to reduce the radical, but in this case we do. We get 9. And that makes sense because if you were to rewrite 27 to the 2/3, remember that in radical form would be the cube root of 27 squared. So the cube root of 27 is 3, and 3 squared is 9. So that's where that 9 comes from. Now I'm not done because I want to solve this. So when I solve, I get -3 and x is equal to 6. I'm not done though because I want to make sure to check my answer. When I plug 6 in there, 6 plus 3 is 9, and if I do 9 to the 3/2 power, I get 27, and 27 times 2 is 54, so this checks out. I could have also put this in radical form in the beginning if I wanted to, so I could have done 2 times the square root of x plus 3 cubed equals 54, and then I could have isolated like I did before. So I could, in this case, divide the 2 and I get the square root of x plus 3 cubed equals, and then 54 divided by 2 is 27. How do I get rid of index of 2? I take both sides to the power of 2. So when I do that, I would get, so I get then x plus 3 equals 729. And then this is all, don't forget, to the third power. So if I want to get rid of a third power, I take the cube root of both sides. So like if I want to get rid of squared, I take the square root of both sides. So this would be the cube root. And the cube root of 729 is 9, so I get... So 2 ways of solving the same problem and getting the same answer. Now, if I look at the next one, I could do the same thing. So I'm going to go ahead and stop here, and we will continue the rest of these notes in class, but make sure that you have all of that down for class.